Hello, dear colleagues and our viewers and listeners. And today we are going to have, I think, fruitful discussion, informal discussion with our colleague Paolo Bussotti from Livorno, Italy. And I'm going to shortly introduce our colleague Paolo. Paolo currently works as a researcher in history of science and technology at university in Udine in Italy. And as I was able to find some information, official information, openly available online, colleague Paolo graduated as first-class honors in history of science and technology from the Faculty of Humanities of University of Pisa. And it's so interesting, in 1991. This year it's also important for me because I am also graduated in 1991, but a little bit earlier, in beginning of June. And Paolo, as far as I know, in November. Some months difference, but anyway, we graduated at the same year. It's so interesting. And for me, it's so interesting because Paolo, as far as I know, he's deeply involved in history of science, history of technology, mathematics, and obviously science. But he's not he graduated in, let's say, pure mathematics or pure physics. As in my case, for example, I graduated as chemistry and biology teacher, and not history, but obviously some parts of my studies also involved some science of history, some parts at some extent. Okay, Paolo, I want to ask you shortly introduce yourself, maybe to add some additional information.
Yeah, thank you, Vincentas, for your introduction. And I begin with my degree. As Vincentas told, my degree is in humanities, is in history of science, but within a humanistic department. After my degree, I got a PhD. I got a PhD in the University of San Marino. San Marino is a little independent state, independent country within Italy. From a territorial point of view, San Marino belongs to Italy, but in fact it's not Italy, it's independent. And I got my PhD, I developed my PhD dissertation in history and philosophy of science. In particular, I studied Bolzano, Gottlob Frege, Georg Cantor, and Edmund Husserl. After my PhD, which was dedicated to foundations of mathematics, I realized that my preparation in mathematics was not good enough. I spoke of something which in my opinion, I did not know sufficiently well. And from that period, at the end of the PhD, I was 30 at the end of my PhD, I began to study mathematics. What means to study mathematics? That I read a lot of books and papers written by classical authors, Archimedes, Gauss, Lagrange, Euler, and so on. And at the same time, I read several handbooks dedicated to several argument analysis, complex analysis, differential geometry, theory of relativity, and so on. And I got a real passion for mathematics and physics, and therefore, from when I am 30, my field of research became history of science and history of mathematics, but developed from a technical point of view. What does this mean? This means that I analyze the methods and the demonstration developed by various mathematicians, physicists, and I compare them. I try to complete them when they are not complete, and I insert these methods within their historical period. This is my work. To give some example, I have written a book on Leibniz planetary theory. This means that I explain Leibniz planetary theory, I compared this theory with Newton's theory, and I explained which were the most important novelties of such theory. This is, of course, I also included this theory within the general philosophy developed by Leibniz. This is only to give an example. I faced Charles, who is a French mathematician, lived in the 19th century, and I wrote several papers and books on history of science and mathematics. Basically, I studied the Greek period, the 16th and 17th century, and geometry in the 19th century. These are the main subjects I studied and on which I published. Starting from 2010, I also developed a profound interest toward science education, toward physics and mathematics education. I have to say, this is the mere truth, that the collaboration with your journals, Vincentas, was an important stimulus for the development on this interest. It was very important. And now I have also several publications, and I continue to publish, not book in this case, but papers, on the relation between history and mathematics education.
Okay.
This is my preparation with regard to the subjects, so to say. Now to come to my academic career, let us say, after my PhD, I had an Alexander von Humboldt Fellowship in Germany, in Munich particularly, 2 years, where I studied a demonstrative method by Fermat called infinite descent. And after that, when I came back to Italy, I had some fellowships, but not a fixed, a permanent job for a relatively long period. And after that, since 2015, I work at Udine University. I have been a researcher. Now I am assistant professor, and in a few months, I think in 2-3 months, I will become associate professor. And 10 days ago, I made an application to get the habilitation for a full professorship. This does not mean that I automatically became full professor, but that I can get an habilitation. Automatically, I will become in 2 or 3 months associate professor. So this is my, so to say, career and some of the scientific contributions.
Thanks, Paolo. It's really quite large and detailed picture from my perspective. It's really interesting, and let's say your experience is obviously complex, large, and rich. I would say it's really interesting, and I think we will return back later on to some issues related to history of science, obviously, and maybe we will discuss in more details. But let's speak shortly about let's say current state of the art, because in different discussions. It's also in my during my lectures with students. It's so interesting to discuss about education systems in different countries, about some situation, current situation, and possible some perspectives. And can you briefly describe, let's say, education system in Italy, in your country today, at some extent?
Yeah. So, to describe the educational system in Italy is very easy until high schools. After that, this becomes a little more complicated, and I hope to be clear. So, the education in Italy begins at 6 years, when a child is 6 years old. And there is an elementary level, and this elementary level is 5 years long, from 6 to 10. And this is equal in the whole Italy and is equal for every child. There is no difference. There is only one kind of elementary school. After that, there is the middle school, 3 years. That's the same as the elementary school. They are equal in the whole Italy and equal for every guy and girl. No difference.
Does it mean up to 8th grade? Right?
Exactly.
Okay.
From the age of 11 to 14, there is the middle school or mean school. I don't know the correct expression.
According to some European Commission recommendations, this is or British, let's say, system. This is lower secondary and secondary school, because it's so common terms, but obviously some differences exist among countries, but. For example, in American English, it's typical to use high school or senior high school or junior high school or elementary at the same time.
Okay, junior high school maybe fits better. Junior high school. Okay, junior high school from 11 to 14, and there is only one kind in the whole Italy. Only one kind. Okay, after that, the senior high school begins. And here there are a lot of differentiation. Let us begin with the most classical schools. They are the licei in Italian. I think licea in English can be translated. And basically there are two kinds, classical and scientific. The classical liceo is characterized by the presence of Latin and Greek. Latin and Greek are the main subjects. Of course, until 20 years ago, it was a very old conceived school. For example, English existed only the first 2 years. The last 3 years, because it is 5 years, there was not English. Now things have changed and English is for 5 years. And there are some sections. For example, there is a mathematical section of classical school, but basically it is centered on Latin and Greek. This is classical liceo. After that, there is the scientific liceo, and it is divided in several sections. There is a humanistic sociological section, there is a physical mathematical section, there is a chemical biological section, and there is an artistic section. Basically 4 sections. These are the licei. After that, there are the technical schools. In the technical schools, it's not exactly, but so to say, they prepare for the future faculty of engineering, and there you became an expert in electronic, electrotechnics, informatics, and so on. And the technical school is, so to say, at the same level of the licei. It's the highest level in the Italian school. After that, there are schools of a little lower level, and they are the school to become accountant or to become surveyor. In Italian we say ragioniere, accountant, or geometra, surveyor. Okay, there are these two kinds of school, and after that there is an even lower level, and which are the vocational, the professionalizing school, where you can become for example, a mechanical, you can become we can say, dental technician, and there is also a section where they teach you how to manage with messages and so on. This is more or less the structure of our schools. Every school is conceived in 5 years, and basically there are not distinctions between the different sides of our country. It's the same in all the national territory. So this is basically the structure of the senior high school. And after that, there is the university, which is conceived more or less as in all the other European countries. There is a first level university, which is 3 years long, and you get a first level degree. And after that, there are 2 further years, where you take the through degree, your bachelor, in which you became bachelor, the true degree. And after that, you can try to enter the work world, and that's not easy. And of course, we have some PhD, but the number of positions for the PhD is relatively restricted, relatively limited. And after the university level, it can happen that many young Italians go abroad. Basically, England, after Brexit, not so much.
Yeah,
but French, Germany, and Benelux are the most desired countries, so to say. And USA.
Just to continue their studies, or for work, just to get a job. Why
when they go abroad?
Yeah, why they are going?
Okay, there are several reasons. The main reason is that if you have a relatively high level of specialization, for example in engineering is a typical example, you find more possibilities to find a job coherent with your knowledge in French or in Germany or in England than in Italy. This is the main reason. Of course, you can find in Italy, for example, from some years, Milano became a very important European city, and Milano is attracting many people from Italy in this moment, many people. But in other parts of Italy, there are problems for employment, and many people who have a specialization go abroad. And the main reason is to find a job coherent with their capabilities.
Yes, it's fully understandable, but having in mind that Italy, let's say, it's not small country, At some extent, it's quite large country, and despite, for example, some possible differences, having in mind South Italy and North Italy. But anyway, this is a big country, and it's a little bit strange. Why need to go abroad?
Yeah, it's relatively strange, but it happens at many levels.
In case of Lithuania, for example, because as we are a small country, and as you said, some specializations or some professions are so narrow, and possible you need to find a job or good position somewhere abroad in some companies, for example, as you mentioned, related with engineering, technologies, ICT, etc. Because Lithuania is small and it's let's say mobile country.
Yeah, I give you the example of my discipline. I myself worked long time abroad. I spoke of 2 years, but in fact I worked more than 2 years. 2 years was the main employment, so to say, the von Humboldt Fellowship, but I had other fellowships abroad. And some very good experts in history of science who are Italian, work in French, because they didn't find their job in Italy. And so, yes, the situation is relatively variegated in Italy. I have to say that in these last years, there was a certain improvement of the situation, but it's not yet comparable with France, with Germany, with England, and so on.
Okay. And obviously, despite some similarities, if you would compare, for example, Lithuanian education system and Italian education system, at some extent they are the same. Some possible similarities, but obviously some real differences. For example, because our system currently consists, let's say, on the formula 4 + 4 + 4. It means that for 4 years primary school, 4 years pro-gymnasium, we call pro-gymnasium or lower secondary level, and 4 years gymnasium, upper secondary level. My next, let's say, question, it's somehow related to that, because despite that we're living in 21st century, it's so modern nowadays to speak about that. Yes, we are living in 21st century, and I'm quite often arguing with my students, and not only with students, for example, about competences. This is quite modern now to speak about competence at every level, everywhere. We should form 21st century competences. I am asking, okay, but only 20 years passed of that century. In front we had approximately 80 years. Who knows exactly what competences do we need? Let's say, okay, now maybe in some near, closer perspective, but not, let's say, after 30 or 50 years, etc. And despite that we are living in the 21st century, the age of technology and progress, obviously, we still face a variety of challenges. And for example, in Lithuania, let's say, so fresh and hot discussion currently about, let's say, school network, because the last decade in Lithuania, this debates on the progress about school network, how to optimize it, and obviously a lot of schools were closed. And the idea was to introduce, let's say, gymnasium system, as I said before, gymnasium and gymnasium. In cities, in bigger cities or bigger towns, it works quite well, I would say. But for example, in rural areas, in countryside, where in relatively small village or district center, where is possible only one gymnasium. And for example, Currently, discussion is in some maybe 3 or 4 years perspective to optimize again this network. And I discussed, for example, with my colleagues in some districts near Šiauliai, and they said, in such a case, we will need to close, for example, approximately all our gymnasiums, because one of the requirements is to have a bigger class group, around, let's say, 30 students, not like, for example, in some cases currently we have 12, 10 in some cases, maybe less, 15, etc. But requirement, let's say, this threshold, it will be more higher, etc. And obviously some gymnasium, not only gymnasium, but some schools will be needed to be closed. It's really a big challenge. And my question is about possible, perhaps you can identify some current challenges for your education system in Italy.
Okay. I think that there are many challenges for educational system in Italy. They are not, in my opinion, they are not connected with the lack of schools, because in general in Italy the situation is like this, that every little country has its elementary and its junior high school. There is in every little country. While if you want a senior high school, you have to go in bigger centers. But anyway, there are the trams, there are the communication means which come to the house of every student, take the student, bring him in the school and bring him or her at home once again. Or anyway, there are many trains, and so this is not a big problem, I think. I think that Italy has a great challenges from the point of view of the content, of the teaching. And in particular, I think that the teaching level became too low. The level is not more adequate for a senior high school. For example, it's very difficult to, I don't know how to say, bocciare. It's very difficult that a pupil, that a student does not go to the following class. It's very difficult. In Italy, 95% of pupils go almost automatically to the following class. Almost automatically. There is no failure in practice. There is no failure.
It's the same. It's the same in Lithuania, not only.
And I think this is not positive. This is a negative thing, because many students arrived at the 5th year of their senior high school and they are not prepared enough for the future in the university or in the world.
But Paolo, I got your position. It's really complex, I would say, and really difficult question, because you mentioned that quality of teaching and learning, this is going down somehow. It's not at the appropriate level. And for example, in case of our current reform, the school network, the main argument is that in bigger schools, the quality of teaching and learning will be high in comparison with, let's say, smaller schools. I think this is not so reasonable, not so good argument. In opposite, in some smaller schools, you can, I would say, control teaching and learning process more easily. I do understand that the question may be related to material basis, to some equipments, instruments, some technological supply, etc., etc. But it's possible to solve. Our schools nowadays are relatively rich, no problem. And you also mentioned that this is quality issues is the main concern.
Yeah, I understand what you mean, Vincentas. And of course, I am not saying that we must adopt a school, an old style school model. I am not saying this, of course, because it was not good for other reasons, of course. So I am not saying this. But I am saying that some alternative model has to be found, because I think that things at the moment are not working in the correct way, are not working. And my impression is that I told you, of course, there are also technical problems. For example, in many schools in the laboratory of physics, there are not good instruments, and of course it's difficult to make physics without good instruments. This is simply obvious. But there are also reasons connected with the relationship between teacher and pupil, that now this relation is became, in a sense, too familiar. In a sense, it's became less professional than in the past. And of course, I understand perfectly that we are not more in the past, and that it was not a good model for many other reasons. But this does not mean that we have to make the teaching level lower. Probably we have to think of new teaching methods. I agree on this, that we have to find new teaching methods, and may attempt to connect history of science and history of mathematics with mathematics and science education is also an attempt in this direction. Why do I say this? Because at least in Italy, the most problematic subjects are physics and mathematics. Absolutely without any comparison with the other subjects. Without any comparison.
Paolo, I would say that I totally agree with you. Because currently, personally, I am involved in international project Erasmus Plus, and together with my colleagues, with our team, we are working on so-called bridging courses in science and mathematics. And our coordinator is University of Vienna in Austria, and from Faculty of Mathematics, colleagues from Faculty of Mathematics. And it's interesting. By the way, our partner is from Italy, from University of Palermo.
Okay.
Yeah, and also from mathematics. And he also said that really it's so problematic. Students' knowledge in mathematics, and I'm talking about students who are entering university, first-year university students. They are not familiar enough with math knowledge, with physics, science in general, physics, chemistry, or biology knowledge, and they entering and with intention to continue this study program. And this is interesting. I am not talking about students who, let's say, entering some other subjects like humanities, for example, or primary school pedagogy or pre-primary education, etc. This is also obviously problematic. But students, let's say, target group who intentionally want to continue their studies in science or math, it's problematic, obviously.
Yeah, it's very problematic, and so we have to, for sure, we have to find some methods to teach mathematics and physics, so that students became more passionate toward this discipline. There is no question about this. Why do I say this? Because This subject, it's obvious, they are very important in school because they are important for engineering, they are important for mathematics at the university, they are important for physics, they are important for chemistry. This means they are important for every branch of scientific knowledge. And we know that scientific knowledge is at the basis of our progress. Therefore, we cannot be happy if only a restricted number of students becomes good in this subject. Because in a sense, there is a sort of natural selection. I mean, either one student is outstanding. In this case, in a sense, it's useless that he goes to school. Or if you are a good student, but good at an average level, but you are a good student, if the teaching of these disciplines is not adequate at the school, after that, if at home you have a parent who is good in these disciplines and he or she educates you, then you can reach a good level in this discipline. Otherwise, your level will remain relatively low and you are excluded from the high-level march of work. And this is not satisfactory from a social point of view, in my opinion. Well, in Italy, many say, and not only in Italy, I think, I don't know, but I don't think that this situation pertains exclusively to Italy. Many say, the school must be democratic. And I agree that school must be democratic, but democratic does not mean that the level must become low, because this is exactly the way to avoid the school is democratic. Because
I agree. Sorry, I agree with you because, as I mentioned before about our current reform, which is on the progress. Next argument or second argument is, yes, we want to keep equal opportunities. For example, as students in big gymnasiums in cities have so good opportunities. I mean, they have good equipment, laboratories in gymnasiums, etc., in order to learn science and mathematics. But I do not see equal opportunities at some extent. For example, we need to bring the students to particular school. With transport issues. For example, if school is located approximately 30 kilometers, up to 30 kilometers, somewhere in center of the district, you need at least some hours to go to school in the morning, and at the same time after lessons, after school time, you should return back home. Again, it requires time. It's time-consuming activity. And for example, if in city students after school time they can continue in some non-formal institutions. For example, some sections, some workshops, some like music school, like dancing, like I don't know, everything, robotics, for example, etc. But in rural areas, in countryside, in villages, he or she, I mean, students should return back home. It takes time. And I do not see.
I understand.
Maybe it's somehow similar in Italy, because Italy also, you have in my territory some distances, etc.
No, of course, there is also this problem that if you live far from the school, you spend much of your time on the trains and so on, and when from a rural area you come to school and you have to come back to home, you are tired and you do not have neither time nor concentration for study. Therefore, yes, there is also this problem, of course, there is. And in Italy, under this respect, there is a very differentiated situation from region to region. That is, in the north of Italy, the situation is far better than in the south of Italy. Because there are more schools, there are more transportation means, and so on. And in the end, this is not necessarily something good, but there are less rural areas in the north of Italy, while in the south of Italy there are several rural areas, and therefore there is this problem as well. And so there is this problem too. And coming back to my previous reasoning, for example, one of the problems of mathematics education is that many issues are treated in a sense mechanically. That is, only like a series of formulas. So, series of formulas and in case applications, but the logics through which these results are obtained, the part concerning the demonstration, the constructive part of the reasoning, is disappearing, and this is a pity. And this is the way to offer mathematics as a mechanical discipline with no fascination, whereas it has a lot of fascination. For example, one might think of speaking of the concept of infinity. One might speak of the difference between a synthetic and an analytic demonstration. These are subjects rich from a conceptual point of view and who might be interesting for the pupils. Whereas this part is not considered, these sections of mathematics are not considered. And the teaching of mathematics is very fragmented because too many subjects are taught: statistics, mathematical analysis, analytical geometry, set theory, and so on. Too many. It's better to teach less subjects, but in a conceptually ripe manner, in my opinion. Therefore, of course, it's not only a question that the students are less prepared or that the teacher is less prepared. It's also the structure of the program of mathematics which has to be retaught in my mind.
Okay, Paolo, it's really it's so interesting. Let's move to our so-called next part of our discussion. At some extent, we already entered to this area, history of science and technology, and because this is, I feel, your favorite area, and I just want to start from a very interesting book. I hope that you know this book quite well. In English, it sounds "Measuring the World." This book is translated into Lithuanian language, and some years ago I bought it, and it was really very interesting reading. I just want to shortly remind this book is written by Austrian writer Daniel Kahneman, and in the center of this story are two young Germans that set out to measure the world of enlightenment, event of enlightenment. One of them, obviously aristocratic naturalist Alexander von Humboldt.
Yeah.
Obviously. Negotiates jungles, voyages down the Orinoco River, tastes some poisons, climbs the highest mountain known to man, counts headlights, explores and measures every cave and hill he comes across. And the other man, very famous virally socialized mathematician Carl Friedrich Gauss can prove that space is curved without leaving his goal. And let's say this story is describing around these two famous personalities. Obviously, I am not professional as you are in history of science and technology, but anyway, during my studies at university, as chemist and biologist, chemist and biology teacher, we had some historical knowledge, let's say, at some extent, but not enough. And it was not, I am not going to speak about history, because history at that time, it was before 1990s. It was oriented to another, some political, let's say, shadow, etc., etc. But anyway, when I worked at school as teacher, obviously some historical knowledge, some historical issues were involved in different lessons, in different topics, explaining, for example, Aristotle, Plato, etc., etc. Obviously, it was needed to start from that time. But in particular, this book that I mentioned, Measuring the World, in Lithuanian it sounds Pasaulio matavimas. This is exact translation, very good translation, how to measure the world. I was really impressed about this book. It's written in very, very nice, very motivating manner. And can you shortly explain or introduce this area, I mean the history of science and technology? Why is this important?
Yeah, okay. Well, Vincentas, why is it important is a difficult question. Yeah, it's a very difficult question. I might answer why is, for example, literature important, or why is history itself important. It depends on what you mean by important, of course. So I think that the main reasons are two. There is an intrinsic reasoning, and history of science, at least developed from a conceptual point of view, therefore not as history of, for example, scientific institutions or scientific biographies, but developed studying the concept and the methods used by the scientists, teach us how the great human minds of the past reasoned. What was their way of reasoning? And of course, this is an important issue because you can compare, because first of all, you can understand what level they reach having less means available than we have. I provide you with an example. Let's take Archimedes. Now we have integral calculus, and with integral calculus it's relatively easy to calculate areas and volumes. But Archimedes did not have the integral calculus, and therefore he invented basically two methods, which is exhaustion method and the method of the barycenter, through which he calculates the areas and the volume of several solid figures. And it's a very exercise of genius, because you realize how genial, how clever was Archimedes to reach these results with relatively few means. And of course, what I am saying for Archimedes is true for Newton, is true for Euler, is true for Gauss, and so on. So there is an intrinsic reasoning. And after that, there is also, I would say, diachronical reasoning. That is, you can see that the history of science has several developed steps. And so you can see how a successive author exploited that knowledge from the previous author, and you can guess a very chain of knowledge. Of course, this is not a continuous chain. What I mean, that for example, at the beginning of the Middle Ages, this kind of knowledge was interrupted, and the knowledge in Europe, you know better than me, became of very low level at the beginning of the Middle Age. All the Greek knowledge most disappeared, and after, at the beginning of the New Age, 16th century, the knowledge of the Greek became once again available, and it was overcame, and at that point a continuous series of steps began until new science. These are the reasons. And I think that to understand how our knowledge has been constructed and how this very clever mind reasoned can teach us something, or can give us also a humanistic message. What I mean humanistic message? I mean that those clever minds reasoned more or less as the clever mind who work nowadays. Therefore, in my opinion, in a sense, there are two tendencies in history of science, two opposite tendencies. A tendency which says each epoch has its set of knowledge. Each epoch has its specific way of reasoning, and from an epoch to another, the mental model change, and therefore the whole process of knowledge change in a sense.
It's as Tom Kuhn saying paradigm.
Exactly. Good. It's exact. While there is another tendency who says, obviously, Greek science, 17th century science, 19th century science, obviously it's not our science, but basically the way of reasoning are, if not similar, at least comparable. Okay,
Paolo, but I know that obviously you are able to explain as large as possible and in different details, etc. But having in mind, I am returning back to 21st century, and we are living in so-called consumer society. Yeah, we need everything fast. Knowledge, we should acquire knowledge in a fast way. We should acquire educatedness as fast as possible, please. Yeah, why to study 4 years, for example, or 6 years? It's enough. Maybe 3 years, or maybe 1 year. It's enough. Nobody knows. As fast as possible. From your explanation, somehow impression is we should go into details. We should go some back. Yeah, should analyze step by step some sequence in knowledge, in understanding, etc. Why do we need to study in such a way? But we need to be fast. We are living in 21st century.
Yeah. I guess there is this challenge, but I repeat what Gauss told. Gauss told, and he was Gauss. Gauss told, pauca sed matura, which means few things but well done. Study and prepare few things, but study and prepare those things profoundly. Otherwise, you remain only at the surface of knowledge, and at the surface of everything, in a sense. Therefore, I understand the necessity, the tendency that everything is faster and faster, but in a sense, I think that it's not completely favorable to get a good knowledge. Some slowness is necessary on some occasions, in my opinion.
Yeah, but who cares about deep and large knowledge? It's like a fast food. Some years ago, I published one small paper, like editorial, about McDonaldization of education. It's like raw, like fast food. Yeah, we are consumers. And I remember one episode from that book that I mentioned about measuring the world. Humboldt, they started to perform measurement of some small hill somewhere outside. Yeah, and local people started to let's say, to fight against them. What they are doing here? Maybe they are shamans or some bad people. Yeah, I mean that possible every time scientists, scholars are in front line. They are working like in front, yeah, to understand world, to understand phenomena, to etc. etc. But it's not important for general society, for public at large. I'm saying at large. And we can observe nowadays, for example, in context of pandemic, at some extent, vaccines from one side, as scientific approach. We should vaccinate, we should elaborate vaccines, etc. We should be vaccinated in order to preserve our health, etc., etc. But some part of people of society against. Why?
They are crazy.
This is not science. This is something artificial.
Yeah, I know. But this is incredible. And well, with regard to pandemic, I have to say that many people who also have a high-level education are against the vaccines. And this is, for me, is incredible, because I can't understand why. I cannot understand the reason. Well, they speak of freedom, but what freedom is to claim that I am free to have a gun and to and to kill people, because this is the same situation. And if you are not allowed to have a gun, then you are not free. But this is crazy. This is simply crazy. And at the same time, I think that in a sense, vaccines were a miracle of science, in a sense. And this is due to people who, not only at the moment, but for long years, studied problems connected to the diffusion, to the spread of viruses. And of course, I understand your objection, that is to say, most people go fast. And this is true. Most people go fast. And as a matter of fact, they are not interested in science. But people who are interested in science cannot go fast, or at least, if they have to go fast in a brief period, for example, for the vaccines, they must have gone slow for a longer period. That is, in the period of their preparation, in the period in which they studied, and so on. Now, the cultural heritage, the formation of a scientist is even longer than in the past, because of course there are many things that is necessary to study. In general, they are difficult things, therefore you need time. So it's true what you say. in a sense, it's perfect, the expression you used. In a sense, the scientists are a front line whose life is different from the life of most of other people. This is absolutely true.
Yeah.
This is absolutely true, and this was true. And this was true in the past. For example, Archimedes did not have the pressure to give a demonstration in 3 days. If 2 months were necessary, he had 2 months available. And basically, the good level science, under this respect, is the same. Of course, you have to work hardly, but you are not certain that your result will come out in 3 days. Otherwise, it's not scientific research, it's something else.
Yes, but it's I would say, continuous contradiction or fight between science and anti-science or fake science or pseudoscience, because it's two confronting areas, and we can observe easily every day. Let's continue have a discussion, and I want to be as moderator in opposite somehow, because the following saying is often have in various debates, various discussions, academic or non-academic. Who cares about history of science? Can you comment on this shortly?
Who cares about history of science? Okay. I comment in this way, and in a very open-minded way. I think.
Obviously, because you are open-minded person.
Thank you. I can say, okay, I understand that someone doesn't care about history of science, as I understand that someone does not care about history in general. In this sense, history of science, in my opinion, is not different from political history or from economic history. It is at the same level from this point of view. And therefore, I am not claiming that my subject is better or particularly interesting or superior to other subjects. I say that my subject is interesting for me, and I try to develop this subject as serious as possible. And I think that the important is that when someone deals with the subject, he deals with this subject seriously. This is the important. It's not important the subject. If one is interested in studying the teeth, that's okay. No, this is only an example. No question about this. Okay, you studied the teeth seriously. I can say that probably to have a historical knowledge of how the knowledge of teeth was reached can give you an open mind that perhaps can be useful also in your present research. I can say this, and it's not by chance that many physicists and many mathematicians are interested in history of physics and history of mathematics, because of course they want to understand how their concepts are born, and probably they presume that it's possible to draw some good ideas from the great scientists of the past. But I am not saying that history of science is compulsory or mandatory or superior to other fields of knowledge. I am saying that it's interesting for me, and I think that there is a very important conceptual support to understand the present state of the disciplines, independently of the discipline. Of course, basically, I study history of physics and mathematics. But, for example, I like also history of evolution, history of the human evolution. I am absolutely not a professional in this field, but I have read a lot of books. And so it's very interesting, per example, to know how evolution arrived at our human beings. It's very interesting. Of course, one could say, okay, I am not interested in this, and I have no objection, but there is no doubt that from a conceptual point of view, it's interesting to know our evolution, as well as it's interesting to know the evolution of mathematical or physical ideas. I have to say, this is my main interest. Of course, I think also the history of science and mathematics might have an application in science and mathematics education. But Vincentas, to be honest, I have to say that I would be interested in history of science and mathematics even if they would not have an application in the education field, to be honest.
I do agree, because generally speaking, scientists, scholars are like a minority in our society, minority and majority. This interaction between majority and minority, scientists are minority. But in addition, as I said, I'm going again to this direction, from members of the public, from science educators, finally, from practicing scientists, we often get very skeptical questions. I remember also during Baltic Sea Symposium, during your presentation and some other colleagues, the same questions about the usefulness of such a work. Can you comment again shortly? Is it useful nowadays?
You refer to application of history of mathematics in education?
Yeah, history of science and technology in general. Is it useful? Is this work useful to analyze, to be interested, to work in this area?
Yeah, of course. I think that my work is useful for inquiries in history of science and technology. Of course, it's devoted to that kind of subject. But I think that it might be useful, as I told, for educational questions, because I give you a concrete example. Let's consider a concrete example. Suppose, as I told, you have to study how to calculate the volume of a certain solid figure, okay? Or the surface, or a certain surface. Then, of course, you have two possibilities. Basically, you have two possibilities. Either you say, I don't care about history, and I teach you integral calculus in a formal way. So introduce the notion of limit, you introduce the notion of derivative. After that, you arrive at the notion of integral, and you explain that through a definite integral, you can calculate a certain area. And of course, I do not condemn this way of proceeding. If this way of proceeding, if developed correctly, it's in order. I say that, in my opinion, it's far more interesting to analyze how you reached integral calculus. Of course, I don't claim that you have to repeat all the historical steps towards you reach integral calculus, but to say, okay, my dear student, you are in front of this strange figure. How do you think to calculate its area? What is your idea? So, let's try to solve together this problem. Let's try from the ground. How do you think to solve this problem? And probably, if you approach the question in this way, it's more stimulating for the students. And it's sure that a solution such that of Archimedes is in a sense more difficult, but in a sense more intuitive than the solution through integral calculus. And therefore I might say, okay, through this method, Archimedes method, it's not necessary to say that it is of Archimedes in a sense, but through this method you can reach some results. Are these results the most general? They are general enough, but they are not the most general. Is it possible to extend this concept? Yes, it's possible through the integral calculus. Then you reach several aims. You explain why the concept of integral has been introduced. It does not arrive from high without any understanding. You understand why it has been introduced. You understand that behind this integral calculus there was a hard work of genial people, and that therefore mathematics is not something mechanical, but something conceptual which needs the work and patience. So you also reach a human message, not only a mathematical message. And so I think that history of mathematics and of science, yes, can be useful under several perspectives: conceptual, educational perspective, and who knows, this I am not able to say, but who knows, maybe studying something of all mathematics, of the best of the old mathematics and scientists, new mathematics and scientists might draw some ideas applicable, which they didn't know and which are nowadays applicable. And this is the reason why I explain in detail the methods I am studying, because I also hope, I don't know if this is possible, but I also hope that they might be useful for some scientists, some mathematicians nowadays.
Just again about, because we are talking in any way about history of science and technology, or mathematics, or science disciplines, but generally this is a relatively young discipline. I mean, the history of science and technology, isn't it? Because majority of works published since 18th century and mainly in 20th century. It's a relatively young discipline.
Yeah, it's relatively a young discipline, and this depends on many reasons. Let us say, for example, when you live in the 19th century, you are a mathematician or a physicist who live in the 19th century, at the beginning of the 19th century. Then history of mathematics and history of physics belonged to physics and mathematics itself, because mathematics in the 16th and 17th century, in the 17th and 18th century, was studied by many people, but not by so many people. Therefore, one great scholar, such as Lagrange, such as Gauss, such as Laplace, were able to control the whole of mathematics. So Euler, who lived 60 years before Gauss or before Laplace, was not considered as part of history of mathematics. Euler belonged to mathematics. Gauss learned number theory studying Euler, for example. And Gauss worked at the beginning of the 19th century. Euler in the middle of the previous century, therefore 50, 60 years before Gauss on our age. So, what happened in the 19th century? The 19th century was decisive from this point of view, because in 19th century, mathematics and physics had a real explosion. A lot of new branches of mathematics and physics were born, and no one at the end of the 19th century was anymore able to control the whole of mathematics and physics. No one was, maybe Poincaré, but not completely neither Poincaré. So, in that period, the necessity to have a view on how mathematics and physics developed became a necessity and became something different from studying advanced physics and mathematics. Because at the end of the 19th century, advanced physics and mathematics was mathematics and physics of the last 20, 30 years, whereas history of physics and mathematics began to have a relatively long history. Therefore, it was felt the need to separate the two fields, to separate the field from advanced mathematics and physics from that of history of these disciplines, whereas 1 century before, this necessity did not exist. This is the origin of history of science and history of mathematics. Afterwards, obviously, each branches of knowledge develops proper problems and proper methods. And so, history of science developed a series of methods and a series of different approaches. I mean a technical, a philosophical, and sociological, a biographical one. It becomes a different subject of academic research. But this was possible and this made sense only around the end of the 19th century, because before, what we call history of the discipline was a part of the discipline itself.
Well, it's so interesting and quite detailed explanation. I like it. Thanks a lot, Paolo, for that. And let's continue. And you, I think I am right that you represent field of science education at some extent. And it would be interesting to know more about how you assess the state of science education in Italy, for example, because it's this area becoming more and more relevant, having in mind I'm speaking in general, some orientation to social sciences, to humanities, for example, at general school level. Last maybe 2 decades, I remember very well, for example, majority of at universities, for example, study programs like social science management, education, etc., sociology were so popular, and a lot of students entered at universities to study this. But currently, not currently, but some last maybe decade, and currently we are speaking about STEM education, for example, about science education in general, and it's really important in different countries, because every day I am working with different papers, for example, submitted to Journal of Baltic Science Education, and we are receiving a lot of papers from different countries, like Asia region in general, Indonesia, Malaysia, China, Saudi Arabia, for example, Africa region, from African countries, Latin America, from whole the world, obviously. And then one impression is that science education is relevant, it's important, but the main concern is low motivation of students, low interest in science, and engagement in science. And please, some words about science education in Italy.
Yeah, okay. With regard to Italy, I have to say that there are the same problems. That is, there is on average, not for all students this is true, but there is a scarce interest towards scientific education. And we have to distinguish. There are many people who are interested in a technical scientific education. Technical scientific is a successful kind of education because, for example, in Italy, some of the most successful faculties are informatics and engineering. Therefore, of course, this is a scientific education, but it is, so to say, a technical scientific education. Therefore, under this respect, there is no crisis in Italy. There are many young who go to engineering or who go to informatics. The situation is completely different with regard to more theoretical part of scientific education. And for example, typically, physics and mathematics have relatively few new students each year. And what is worst, many of these students abandon these faculties along their academic career. It's typical that one begins with mathematics, he or she fails or find mathematics too difficult, and after that go to engineering or to informatics. And of course, this implies, and I am seeing in my university itself, and I am seeing my university too, this implies what I told before, that is, that the difference between the level offered by the senior high school and the beginning university level in faculty as mathematics is enormous. There is an enormous gap, so that many students, when they begin to make mathematics or to make physics, are disoriented because they are in front of concepts which are taught in a very more profound way. They are not used to reason in that way. Therefore, it's not question of subjects, because at the first year of mathematics, the subjects are similar to those of the last year of senior high school. They are similar. The problem is that the methods, the profundity of teaching is incomparable, and many students find this gap too enormous and they abandon and go to other faculties.
Yes, it's the same, returning back to, as I mentioned about our project, which is in the progress now, ongoing project, and we clearly realized that it's really a big gap between secondary, let's say, school science and mathematics, and university science and mathematics. And as colleagues said, we need to spend extra time, for example, explaining school mathematics for the first year university students, which is, from one side, it's a waste of time, and it's not possible to start from university mathematics or etc. This is really big gap. But I think it's at least my position that it's not in every country, obviously. For example, I visited many times Taiwan and obviously Malaysia, Singapore, and some other countries. And for example, in Taiwan, A lot of students, I would say majority of students, are motivated, highly motivated, and interested in science and technology. Not in social sciences, for example, but in science and technology, because it's like engine of economy, engine of life, and they connecting their future career with this area. And for example, in Lithuania and in some other countries in Europe, situation is quite different. And if you would comment on latest, for example, TIMSS study or PISA study, mathematics and science, I can say problematic at some extent.
Yeah.
Low motivation, low interest, and a lot of papers, scientific papers, research, quite often analyzing these parameters, how to raise interest, how to motivate students, how to attract students, etc. And for example, in Lithuania, some years ago, we launched so-called STEAM centers. Currently, we have 10 regional STEAM centers. And in particular, STEAM Center is responsible for coordination of activities, teaching and learning activities for particular district, inviting schools, inviting students and teachers to work in labs, etc., etc. But obviously, it's not common work, not regular work, because only from time to time school students able to attend, to be invited in these centers and to have some practicum, for example.
Yeah, and Vincentas, of course, I have to add something that with regard to Italy, that in Italy too, now each university has a teaching, as a series of lectures, as an interior course on didactics of mathematics. Therefore, in Italy too, there are studies on this subject. They are not missing. There is an interest toward this subject. But of course, you know, it's a problematic subject and it is a relatively new subject. We will see if research in didactics of mathematics will imply in the near future an improvement of the relation between school level and university level. We will see what will happen. Yeah, of course, there are a lot of studies. I know several colleagues who are endowed, who are interested in this subject and who teach at the university these subjects. Yes.
Okay, but let's connect our previous topic with science education. And my question is, does science education need the history of science?
Yeah, in a sense, in my opinion, I think yes, that it needs. It needs, well, of course, if you begin at the elementary level, let us suppose you are 6 years old. You enter an elementary school, and of course, I don't think that at the level you need history of mathematics to learn additions or to learn multiplications or to learn the most basic concept. I am not convinced that it's necessary, but I think that when you reach the senior high school level, I cannot say necessary, but it's history of mathematics and history of physics might be an important support for physics and mathematics education, because history of science and history of mathematics can teach that under the formal level there is a conceptual level which was developed historically. It was not born in 2 days. It was born in centuries of studies and applications. And I think that I am convinced that this approach might be more interesting and also more fruitful for the students than a formal approach. This is the reason why I think that history of mathematics and of physics can be an help. Of course, I am not saying that it's necessary in mathematics education, but I am convinced that if history of this discipline is appropriately used, it can be a great support, because it can help to understand the concept first, and it can improve the interest towards this discipline. For example, this year I made the course of history. Okay, at the Faculty of my timetable at the university is so divided. Half of my timetable I teach history of science at humanities, and this is one subject. The second half I made history of mathematics and didactics of mathematics at the Faculty of Mathematics. 1 year I teach history of mathematics, 1 year didactic of mathematics. This year I taught history of mathematics. And a good student of mathematics, told me, "Professor, your course was interesting, but I have to say that in your course too, there were too many formulas and too many theorems. In practice, you taught us how the old mathematician made mathematics. This is okay, but in the future, perhaps you might concentrate more on the concepts and a little less on formulas." And this is an idea. This student was honest in saying his opinion, and I told, okay, I don't know if I will change my course, but for sure I will take in account your opinion. And maybe this is the same reason for senior high school. Some less formula and some more concept might be useful.
It's at some extent this is like...
Excuse me, Vincentas, I switch on my light.
Okay. Light is necessary,
okay.
As I said in the beginning, because it's becoming dark. And this is returning back, this is like an additional workload for students. I mean, history of science. Why should we study history of science? Or why history of science should be involved in some my current studies, for example? Because this is additional workload. And another thing is that I'm not going to say modern, because I don't like this naive and at some extent stupid term modern. What does it mean, modern? But current trend that teaching and learning process should be easy, should be fun, should be exciting, interesting, without appropriate efforts from student, particularly from student, because we are forming like a context that learning should be fun and learning should be as a game. This is easy thing, it should be easy, not etc., etc. But in reality, learning, and obviously this is relatively hard activity. We should memorize something, we should develop our thinking, etc., etc. The main cognitive functions should work. Otherwise, it's not possible just to sit in classroom or somewhere else and somebody will put, for example, some knowledge, some information, etc. This is not possible.
Yeah, of course, and But for example, I was thinking of another possible application, and I used this in my courses of history of mathematics. For example, I give you an example. Consider the triangles. A triangle. You consider a triangle. Of course, in reality, no triangle exists, no geometrical triangle exists, because, of course, each side of a triangle, of a real triangle, has a width, while the sides of geometrical triangle have no width, they have only a length. So, for example, it's very interesting, in my opinion, to understand how we reach the concept of a geometrical triangle, of a geometrical line. How did we reach this concept? Did we reach this concept because they were innate in our mind, or did we reach this concept through experience, to experience and abstraction, and so on? And this is another contribution, for example, that history, and in a sense also philosophy of science, can give to science education. This is another contribution, and it's interesting because one pupil, if he is a good pupil, a clever pupil, can say, okay, professor, you are speaking of a length of a side that is a pure length, but when I draw a side of the triangle, it's not a pure length, it's at a width. A little width, but it has a width. How is it possible that you speak a pure length? Then you have to explain, okay, this is possible because there was a historical process, and afterwards you have to connect this historical process with the structure of your mind, with the construction of your brain, and so on. Therefore, history of science can also have a multidisciplinary character, a multidisciplinary approach toward the subjects. And this is important, of course, I think, in an educational context. And nowadays, you know better than me, Vincentas, far better than me, there is the right tendency to interconnect the different fields of knowledge, to interconnect also at an educational level. And thus, history of science, in this case, I can say it's surely an help towards this direction.
Yes, like integrative approach, like integrating relatively different
integrating the main subjects, so to say.
I do agree because it's really true. And we can integrate science disciplines, and not only science disciplines like in STEM, because STEM is not obviously it's not a new approach at some extent. We spoke a lot previously about integrated teaching and learning, integrated approach, etc., etc. This is obviously related. And okay, we are approaching to our last part of our discussion. It's traditionally I want to speak about teacher education because teacher remains the main point in our education process.
I think yes. I think you're right.
I mean, teacher or lecturer or
of course.
University level, doesn't matter, but teacher in general. And teacher education remains a burning issue, I think, not only in our country, I suppose that it's in Italy too. For example, in Lithuania some years ago, our society worked with some so-called national idea, and one idea was about teacher, where teacher profession should be the most prestigious profession in near future, in some years. It's like a strategic goal, this national idea. But obviously reality is somehow different.
Yeah,
and
absolutely.
it's not easy. And mainly, I would say the last decade, maybe not the last. Personally, I am observing a huge decline in quality of teacher preparation and in quality of teacher training programs, etc., etc. And it's from one side. From another side, students who prefer to become a teacher, they are not motivated enough. Initially, not motivated enough. I'm usually saying that we have a lot of accidental teachers who, based on some circumstances, they are working at schools, or for example, young people entering study programs based on different motivations, based on different reasons. It is easier to study, etc., etc. Different let's say motives, but anyway, in general, material for future teachers, how to work with this raw material, for example, 4 years, or having in mind, for example, master study level, 6 or 5 years, and to prepare good teacher as good as possible. This is really a burning issue. And moreover, we are speaking about training of a new generation of teachers. They should be highly competent. They should have a lot of knowledge, different knowledge, deep knowledge, competences, subject competences, professional competences, etc., etc. Finally, teacher should be as researcher, etc., etc. What do you think? What is the situation in Italy?
Yeah, I think that the situation, to be honest, the situation in Italy, in my opinion, is not good. It's not terrible, but it is not good. And we have to make a distinction, a fundamental distinction. At the university, if you want to become an elementary teacher, in Italy exists a specific faculty. There is a specific faculty which is called formazione. I think maybe it's possible to translate something like formation. I don't know exactly into English. This faculty is specialized for teachers who aspire to become elementary teacher.
Like primary education level.
Bravo. Primary education, exactly. That's the right expression. Primary education. This is a specific faculty. Every university has a faculty of primary education, and it is full of students. But it's obvious, as you told, that not for many of them it is a vocation. For many of them, they go there because it's relatively easy, because other reason, but not because they have a vocation. Of course, there are many who are really interested in their studies. Nothing to say about this. So, they have, however, a specific preparation for primary education, while nothing exists for high education. There is no specific faculty in Italy. There is only a mechanism like this, that if you are going to become teacher in a high school, independently of the faculty you are following, you are obliged to give 4 or 5 examinations, which are common, and with these 4 or 5 examinations, you are habilitated to become a teacher in a high school. But there is no faculty for high school teacher. For example, if you want to become teacher of mathematics, you give your examination of mathematics, plus you have to give 3 or 4 examinations of this common set of examinations.
Paolo, does it mean, for example, in our case, obviously we have different models for teacher study programs or for teacher preparation, but generally, for example, you can study chemistry, biology, or physics, and finally to obtain bachelor degree in physics or chemistry or biology, and afterward you can continue 1 year study. It means 60 credits, 1 year study to become a teacher, to obtain professional qualification, teacher professional qualification. This is one model. You are bachelor, for example, in different disciplines, in different areas, and after that you can obtain additional 60 credits and to become a teacher. And obviously you can work to continue your work in school. And another study programs or another model is different. This is so-called continuous model. You are starting from first year in pedagogical study program. For example, some years ago we had, for example, at our university, we had program integrated science pedagogy. It would be direct translation into English. Integrated science pedagogy, it means this study program prepares teachers to work at lower secondary level or middle school from 5th grade to 8th grade. And to teach generally all disciplines in science in integrated way: chemistry, physics, biology, etc. Obviously, different models exist. Do you have something similar in Italy?
Okay, that's a very good question, and I answer you in 2 steps. At the moment, no. At the moment. But in Italy, there was a long history in this sense, and I tell you this history briefly. Until around, I might make some mistakes with the years, but the concept is clear. Until I think the end of last century, there was a specific faculty. My mother, for example, has a degree in this faculty, and he was a teacher of history and philosophy, which was specialized to become a teacher. It was called Magistero. You went to the Magistero, you took your degree, and after that you could make an application to become teacher. This was until around the end of the last century. After that, this faculty was suppressed. And what happened? That for a period around 11 years, until 2011, you make a normal faculty, mathematics, physics, engineering, literature, etc. And after that, after your degree, you have a 3-year specialization school through which you were habilitated to be a teacher. 3 years. After that, from 2012 to 4 or 5 years ago, this school was suppressed, and an easier series of steps were developed, not more in 3 years, but in 2 years. After that, you were habilitated to become a teacher. From 4 or 5 years, these steps following the degree disappeared, and you get your habilitation within the university, giving these 4 or 5 additional examinations, but within your examinations at the university, not after the degree, but before the degree.
Okay. And
this is the history, yeah.
And for some period, for example, in Lithuania, we feel like shortage of teachers, or we need more teachers. from one side. From another side, having in mind that some schools are going to be closed, maybe this problem somehow will be solved, obviously. But in cities, in towns, this problem is not so clear, I would say. But in rural areas, in regions, obviously we feel shortage of teachers. Teacher profession is not attractive enough. Not only having in mind salary, but also some environment, some material support, etc., etc. This is really burning issues in Lithuania. And what about Italy?
Yeah. Comparable situation. In Italy, it depends on the subjects. For example, the teacher of mathematics are missing. There are some students of mine who, before ending university, before taking their degree, they are teaching in the schools because the teacher of mathematics are missing. And this is true for physics as well. While there are other disciplines, for example, literature, and there are many teachers of literature, of Italian literature, let us suppose, and in that case, it's not easy to get a position as a teacher. But in mathematics and physics, it's easy. They call you because the teachers are missing. So, two students of mine with 24 years, they also teach in the schools, of course, with a partial contract, but anyway, they are teaching and they are earning.
Yes, I for example, some years ago, not only once, but again, many times I visited Brazil, São Paulo, University of São Paulo, because we have some good contacts with colleagues from São Paulo University, and I was maybe twice I was invited for special seminar for PhD students related to methodology, research methodology, etc. And we visited some schools, some local schools in São Paulo, and I was surprised that, for example, also they feel a lack of teachers. And I remember we asked some schools that students just walking around, no lessons. I asked why, and I received very clear answer: no teacher.
No teacher. Yeah.
Or let's say changing. Teachers are changing quite often. For example, they work temporarily for, I don't know, 1 month, or some months they changing their job and looking for another career, etc., etc. Obviously, I am not talking about so-called prestigious schools, etc. Obviously not, but for public schools, it's so common situation to feel lack of teachers.
Yeah, and take into account, I forgot to say this, that in Italy, almost all the schools are public schools. The private schools are rare, and they are on average of very, very low level. Therefore, when I speak of school in Italy, I refer to public schools, because almost all of the schools in Italy are public.
But obviously you have some private schools too, I think.
Yeah, there are some private schools, but very few.
Private sector.
But very few in number, and they are differently than in England or the United States.
You mean not so popular?
Not popular. They are not very popular in Italy. No.
Why?
No. This is a great difference.
For example, in Lithuania, private schools quite prestigious.
Yeah, in Italy there are few private schools, and on average they are not very prestigious. No, In Italy, the education, at least for the moment, is basically public. Is almost 100% public at the high school level. There are private schools, but of low level. At the university, the situation changed a little bit, but by far, most of Italian students, by far, go to public universities, by far. There are private universities and there are also very good private universities, but they are a minority.
Okay, and just additional question about teachers, because I am not asking about exact level, exact amount of salary for teachers, but having in mind, for example, average in labor market, what is situation in Italy? For example, having in mind teachers, are they well paid or somehow in the middle, or?
Yeah, I would say in the middle. I would say in the middle. Of course, it depends on the level of career, because you enter the school with a certain stipendium. I can also say for a complete timetable, it's around 1,500 euros. 1,500. Which is not much, but for the salarium in Italy, it's an average salarium. But in the years, thought slowly, the salary improves and became higher. And I think that I am not sure, but I think that a teacher at the end of the career earns about 1,800, 1,900. I would say average salary, an average salary.
Okay, Paolo, and time goes quite quickly. And my last question, you mentioned already shortly, but anyway, teaching profession, is vocation a myth, or is it vocation or not?
Yeah, allora, with this regard, I have a precise answer. And my answer is, in most cases, in part is a vocation, in part is a profession. I mean that is a profession that you like. I think this. Therefore, in part, it's not exactly a vocation, absolutely. It's a profession because you earn from this job. But at the same time, in most cases, I have to say that teachers are passionate towards their job. I have a good impression with this regard. Therefore, I mean, in part vocation, in part profession. Yeah, I would say this. Yeah, it's not exactly a vocation, because of course it's nothing religious, for example. It's not like a priest. But of course, most of teachers have a great passion towards their job. Unfortunately, in some cases, no. But this happens everywhere, I think. But in most cases, yes. I think that they have a passion towards their job. Yeah, I think yes.
But this is so close second saying that teaching is like God's calling.
Yeah, I know. It's told.
Yeah.
Yeah.
But I am not going to say that we have more and more accidental teachers, as I mentioned before. But anyway, at some extent, this is quite problematic situation. We have more, at some extent, we have more accidental teachers. Okay, we are working more or less good, like artificial, but yeah.
Yeah, we have two accidental teachers, of course. There are in Italy two accidental teachers. I am not saying that all of them have a passion. I think most of them have, I think.
Okay. Do you have some good recipe how to improve the situation?
To prove my thesis?
No, to your recipe how to improve the situation, for example, to have more the best teachers.
Okay, to have more good teacher, Vincentas, this is a very, very difficult question. I have to say that to your last question, I have no precise answer, because I think, Vincentas, that in every profession, there is always a set of people who make some profession only for interest, only because they see in that profession a job. And this is unavoidable. This is unavoidable for teachers, and I think it's also unavoidable for doctors, sometimes for surgeons. Therefore, we must cohabit with this situation. Of course, there are some means to improve the vocational aspect of the teaching. There are, I repeat, introducing history in the teaching process. I think it's a good idea. Also, for the students at the university who are going to become teachers, and I mean, and of course, but there is also a part of people who make a job who are scarcely interested in the job, and they are only interested in to earn, and this is unavoidable in a sense. I think that's unavoidable.
Thank you, Paolo, because it's obviously so interesting to discuss.
Thank you to you.
We can analyze so different aspects and so different issues, burning issues, which are so important nowadays and maybe for our future. But anyway, our time is limited and we should approach to the end. And so our discussion obviously is coming to an end. And while it's really exciting and interesting, but the timing is relentless. And I want to thank you for your time.
Thank you to you, Vincentas. It was a pleasure.
Obviously, for your interesting thoughts and insights. And at the same time, I wish you great success, in your personal and academic life, in your future career, as you mentioned about your next position or next possible promotion. Good luck to you and to your relatives, and I hope that we will see quite soon, possible online, possible in real life, etc. I hope so. And maybe also you want to say some words, Ben?
Yeah, of course. I have to thank you, Vincentas, for the opportunity I was given. I collaborate with Vincentas from 2012, and it's a pleasure, for me. And I have to say sincerely this, namely that your organization, Vincentas, is very good. And I am convinced that this idea to present scholars from various parts of the world and from various disciplines is very, very interesting. It's a good idea, and to be honest, I am going to speak with the director of my department to propose something similar, because it's really a good idea. I am going to speak with her because I think that it's useful. That is something very useful. Therefore, I thank you and I am grateful to your organization.
Okay, Paolo, once again, thanks you very much and good luck.
Ok, ciao Vincentas, ciao ciao.